Welcome to 10.5. This is base E in natural logs. We're going to evaluate and solve using natural bases and natural logarithms. So to start, the natural base is called E. It is an irrational number. It's 2.71828, so on and so forth. And this is the graph of y equals e to the x. Notice that it crosses about 2.71828 when x is 1. Okay, so the inverse of this isn't a logarithm, it's actually a natural logarithm. And that is because instead of a normal base, common base, it's a natural base. This is a natural log. We write natural logs as ln. So this is the inverse here. It's y equals ln x, natural log of x. And it crosses the x-axis at 2.1. Or it crosses at y is 1 at 2.7. Alright, so let's look at some examples here. We're going to rewrite these as equivalent exponential or logarithmic expressions. When you have a natural base, when you take your log, you actually don't need the e anymore because the base is just assumed as part of the ln. So our exponent is x, so that's what it's going to equal to. This is the natural log of 20 equals x. For our second one, we write it as an exponential. Since it's a natural log, it's e to the, and then the exponent's 5. So e to the 5th equals x here. To solve, to evaluate, we can just type these into our calculator. There is a natural log button. So you press ln 10 on your calculator, and you get about 2.30. Now, natural logs and e's are actually inverses of each other, so a natural log of an e actually cancels. It's whatever's in the exponent that's left. So here we just get x. All right, to solve a natural log, to get rid of this one, we actually want to take everything e to the power of all of this. So it's e to the natural log of x minus 1, e to the negative 2, in order to get rid of the natural log. So e to the natural log of x minus 1 is just x minus 1. And to get x by itself, we're going to add 1 to both sides. So x equals e to the negative 2 plus 1. And this is about 1.14. Our final example here, we're given an equation. It's a equals p times e to the rt, also known as apert. Suppose you deposit 1,125, which is our P, in an account paying 3% annual interest, so 0.03 is our R, compounded continuously. That's why we use E as our base. So what is the balance after 15 years? That is our T. So we're going to put all that into our equation. A equals 1,125 times E to the 0.03 times 15. We type that straight into our calculator. We get 1,764 and 35 cents. So how long will it take for the balance in your account to reach at least 1,500? That's our A. This time we don't have T. Fill it back into our equation. Divide by 1,125 and we get 1.3333 repeated. And then we're going to take the natural log of both sides to get rid of the E. So natural log of 1.333 and then the natural log of e to the 0.03t. That gets rid of our e, so it becomes just 0.03t. If we divide by 0.03 and then type that into our calculator, we get about 9.59 years. So again, the natural log of 1.3333 divided by 0.03 is 9.59 years. Alright, that is it for natural logs and base E. Good luck on the practice. Make sure you get it turned in.